The other thing I wanted to ask, I wanted to sort of get an idea, maybe if you had like an example or something of sort of that outside of like a replacement part, sort of the customer coming and going, hey, we got a problem. We need you to fix something. And I'm sure you run into that a lot. Could you sort of maybe if there's an example or something, sort of walk us through it, just to sort of give our audience an idea of how you'd even approach that?
Okay, so probably the most prominent case recently is with a tool that we created. So we had a customer talking to us about wanting to solve a problem where when they were pulling the steering pins from the steering assembly underneath the 793 truck, the process of doing that was quite unsafe. So in some cases, the knuckle would actually seize in the hole, and so it's a tapered fit. And when you put it in, you screw a nut from the bottom to get it to lock in place. So over time, that would wear out, and you would retighten it, or you would do something to it through the use of the truck, and eventually it would seize a lot of the time. And so getting them back out, there was no easy way to get under the truck, and so people would be using a hammer and drift underneath, or they would be lowering the truck onto a spike so that it would put pressure on it and try and release that stud or pop it, as they say, from the taper. As you can imagine, me just describing the process sounds pretty gnarly. It sounds pretty unsafe. I refer back to the statistical probability. You can imagine it spiking on the Richter of risk and freaking everybody out. And so that process, as sort of risky as it was still taking anywhere between, say, we sort of thought the best one would be maybe an hour, and then the outside one where you had a really seized stud in there would be possibly 12 to 14 hours, which is just, it's a long time to be working, pulling one part from another. So we had a look at essentially like an inverted pressing tool. We had a range of challenges because the surrounding mounting spaces that we could use to anchor from were all cast. And so, as you imagine with castings, they're rounded or they're rough or they're not equal. And so it's not a exactly the same on either side. And so we came up essentially with like a little finger type of system that would hang over the top. We had to re-engineer it a few times to get enough strength without the fingers breaking off. We had to also specially treat the material. And then essentially we got it to rate up. I think the current rating at the moment is around 50 tonne up with no hesitation. And that tool, we also wanted to make it so that one person could lift it. We wanted to make the handles ergonomic. For us, it's this thing where we want to do the right thing by the user as well. And so we made it as ergonomic as possible and got it as light as we possibly could. So the end state was that we got it so that you could fit it up one person, you set it up in about 5 minutes, and it would take you around about 5 to 10 minutes maximum to press a stud. So we were reducing, and there's 8 studs. I think the tool can do around 6 of those 8 studs. So we were reducing, in some cases, the overall steering component change out by 36 to 40 hours.